Hello. Today I am going to work through a number of problems using dimensional analysis. Now you can use any type of setup that you want to for these problems, but I always use dimensional analysis because no matter how simple or how complex the problem is, you can do it with dimensional analysis. So that's why I teach this way, and that's the way I'm going to show you for this. So for our first problem here, we have that the physician or the provider ordered 100 milligrams of a medication, and the pharmacy sent us 25 milligram tablets. So we need to know how many tablets the nurse will administer. So this is a pretty simple problem, and so we're going to set it up here. And I set up my problems the exact same way every single time. So the first thing I do is first note that your milligrams and milligrams match. So that helps that there's not going to be any additional conversions with this. We're already in the same unit. So I always take with first what is ordered. And so in this case, it's 100 milligrams. And again, it's a tablet form, so it's not like in 5 mils of solution or anything like that. So we're just going to put 1 on the bottom, okay, because there's nothing else there. Next, we're going to take what the pharmacy has sent us. So the pharmacy sent us 25 milligram tablets. So because I need to know the answer is going to be in tablets, I'm going to need to get rid of my milligrams. So in this case, I'm going to put my 25 milligrams on the bottom, and I'm going to put 1 on the top. So that means for every 1 tablet of medication, there's 25 milligrams in there. So if you wanted, you can actually put tab here, so 1 tablet. So every 1 tablet has 25 milligrams. All right, so now our problem is set up. So now we just need to do our cross multiplying. So first of all, or getting rid of our units. So because we have milligrams here and we have milligrams here, they cross out. There's no units here and there's tablets left, and we already know that it's going to be in tablets. We know that we've set this up right, and we know that our answer is going to be in tablets. Perfect. So now what we do is just multiply across. So it's going to be 100 times 1. And then on the bottom, we're going to go 1 times 25. All right, I'm going to just kind of move my problem down here. So we know that 1 times 100 is going to be 100. And we know that 1 times 25 is going to be 25. So if we have 100 divided by 25, if you need your calculator, that is fine. 100 divided by 25 is going to equal 4. So that'd be 4. So our answer in this case is 4 tablets. All right. Moving on, our next problem. We have the provider ordered 37.5 milligrams of a medication, and the pharmacy is sending us up tablets that are 75 milligrams each. How many tablets will we give? So right away we know that we're going to be giving tablets, and that's what we're going to be figuring out. So we can put tablets here. That's what I wrote. And then we can see here that this is in milligrams and this is in milligrams. So we're already in the same unit. So this will be another pretty easy one. So we're going to start again always with the same thing, which is what is ordered. So we're going to have 37.5 milligrams, and it's just over 1 because again, it's not in a solution. Next, we're going to put what the pharmacy has sent us, and they sent us 75 milligram tablets. So again, I know I need tablets to be in my answer, and so I need to get rid of milligrams. So I'm going to put 75 milligrams on the bottom for every 1 tablet. Okay. And then I can get rid of my like units. So milligrams crosses out milligrams, and then we can multiply across the top. So 37.5 times 1 over, 1 times 75. So that's going to be 37.5 over 75. So again, if we get out our calculator, we can go 37.5 divided by 75 is going to equal half. So in this case, our answer is going to be 0.5, and so we are going to be giving half a tablet. Okay. Next problem. The provider ordered 360 milligrams of a medication, and the pharmacy sent us up a solution. We don't know if it's oral or IV, but the solution has 60 milligrams of medication in every 2 milliliters of solution. So this one has a little bit of an additional, not an additional step, but additional math that we need to do, or some additional numbers. So again, we already can see here that we have milligrams and milligrams, so that's in the same unit, so that's good. And we says here, how many milliliters will we be giving, so we know that our answer is going to be in milliliters. Right. So let's set it up how we always do. We're always going to start with what is ordered. So we have 360 milligrams over 1. And the pharmacy sent us 60 milligrams in every 2 mils. So I'm going to, we know we need to get rid of our milligrams, so the milligrams is going to go on the bottom. And I'm going to put 2 mils on the top. And here's our problem is all set up. So again, I can cross out milligrams and milligrams, and what's left is mils, and that's perfect because that matches what's over here. And now I can start doing my math. So it's going to be 360 times 2 over 1 times 60. Okay. So if we do 360 times 2, that is going to equal 720. And 1 times 60 is going to remain 60. So then if we get out our calculator, and we are going to go 720 divided by 60 equals 12. So our answer in this case is going to be 12 milliliters is what we're going to give that patient. All right, next problem. We have an order of 35 milligrams, and the pharmacy sent us 100 milligrams per 1 mil. So again, we have milligrams and milligrams, which matches, and we know that our answer is going to be in mils, so we can put our little thing over here, mils, to remind us, and we can start setting up our problems. So what we have, 35 milligrams, and that's going to go over 1. And then we have what the pharmacy sent us, and we know we need to get rid of milligrams. So I'm going to put milligrams on the bottom, and I'm going to put 1 mil on top, because that's what we have here. That's what the pharmacy sent us, and we're ready to go. We can cross out milligrams, and so we're left with mils, and that's perfect because that's what we know we need. And now we can do our multiplying. So 35 times 1 is going to be on top, and then 1 times 100 is going to be on the bottom. So again, 35 times 1 is just going to be 35. 1 times 100 is going to stay 100. So then we get out our calculator, and we are going to go 35 divided by 100, which is going to equal 0.35. So we get 0.35. Okay, but we do know that if we're going to round to the nearest tenth, we do need to round this number because the 3 is in the 10th spot. So looking at the 5, so the answer that we would end up having is 0.4 mils if we were to round to the nearest tenth. All right, next problem. So now this is a weight-based problem. So this changes our stuff just a little bit, but not a lot here, this initial one, because everything kind of already matches up. So we have an order to give a medication that for every 1 kilogram that patient weighs, we are going to administer 5 milligrams of medication. We know that the patient weighs 75 kilograms. It's already in kilograms, so it makes our math a little easier. And we know that the final answer is going to be in milligrams. Okay, we need to know how many milligrams we're going to give based on how much that patient weighs. So I could go like this, and I can go milligrams because that's what my answer is going to be in. All right, so let's set this up same way as always. We're going to take what we have ordered, and so we're going to have 5 milligrams per every 1 kilogram. Okay, so we're going to be giving 5 milligrams of medication for every 1 kilogram that the patient weighs. We know that our patient weighs 75 kilograms. So again, I need to get rid of kilograms because I know my answer needs to be in milligrams. So I'm going to put kilograms on top, and it's just going to be over 1. All right, so there's how our math is set up. So again, we can cross out our kilograms, and what does that leave us with? Milligrams, and that's perfect because we know that's what our answer needs to be in. And now we can do our multiplying. So again, across the top, we're going to have 5 times 75 over 1 times 1. So 5 times 75, if we were to do that math, is going to equal 375 over 1. And we know if we divide 375 by 1, it's going to remain 375. So our answer is 375 milligrams is what's going to be administered. All right. Next sheet here. Next we have a little bit more a complex problem here. So we are starting out, we have what the providers ordered. They want us to administer 1.5 milligrams for every kilogram that a patient weighs. But the information we have here is not in kilograms, it's in pounds. So we do have to do an additional step in this problem because we need to convert pounds to kilograms. So this, what we'll need is this conversion here. So 1 kilogram equals 2.2 pounds. So we're going to have that in the back of our head, and we're going to plug that in here in just a second. So again, I'm going to start out the way I always start out my problems, with what is ordered. So 1.5 milligrams per 1 kilogram. So again, I'm going to give 1.5 milligrams for every 1 kilogram of weight the patient weighs. So now here is where I put in this. You can put it in further into the problem. It doesn't really matter where you put these conversions, as long as you have them set up correctly so that that when you cross out everything that you need to cross out, one's on the top and one's on the bottom. So in this case, I know I need to get rid of kilograms, because eventually my answer is just going to be in milligrams. So I need to get rid of kilograms. So I'm going to take this conversion and put it in right away. And I know that 1 kilogram equals 2.2 pounds. Okay. And so there's where that plugs in. But I still have additional information that I need to plug in, because now I know that the patient weighs 133.8 pounds. So again, I need to get rid of pounds. So for my next problem, or how I'm going to set it up, is I'm going to put the pounds on top. So I'm going to put 133.8 pounds, and that's just going to be over 1. That's just what they weigh. So now my problem is set up correctly. So, and again, I know my answer is going to be in milligrams, so I can put my little answer over here. And now I can start getting rid of like units. So I know I have pounds here, and I have pounds here, and I have kilograms here, and I have kilograms here. And so what am I left with? Milligrams, and that's perfect, because that's what the answer should be in. So now I can cross multiply, and I'm going to just kind of go down below here to do that. So I'll go 1.5 times 1 times 133.8, and that is going to be divided over 1 times 2.2 times 1. Okay, so that's where that is. And then we're going to get out our calculator here. So I'm going to go 1.5 times 1 times 133.8, and I should get 200.7. So I'm going to put 200.7, and then 1 times 2.2 times 1 is going to stay 2.2. So I don't need to do that math, so we're going to go 2.2. So now, whoops, sorry about that. Now we'll have to do some dividing. So we're going to get 200.7 divided by 2.2, and that is going to give us 91.227 da 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 da. So again, if we're going to be rounding to the nearest tenth, this is our number that is in our 10th spot right now. And again, we know we need in milligrams. So my final answer is going to be, 91.2. Right, and that is what the answer will be. All right, moving on. Now our next problem is a little bit more complex as well, because now we have a solution that is in, it's either an IV or a PO medication. So we do have an additional, it's not an additional step, it's just some additional numbers here. So let's set it up here. So again, like always, and we can see that we already have kilograms, and that's going to be the same unit there. So that's great. And then we have micrograms here and micrograms here. So we don't have to do quite as many conversions with this. So we're going to start with what we have ordered. we have 250 micrograms for every 1 kilogram the patient weighs. All right. Next, we are going to put in what the patient weighs. Again, that's just how I set it up because I don't need any additional math like we did up here because we don't have to do this conversion. It's already in kilograms. I'm going to put the kilograms here. So I know that this patient weighs 129.1 kilograms, and that's just going to be over 1. And then we have, this is what the pharmacy has sent us. And we know, so we already know how many micrograms we're going to be giving. So we need to know how many milliliters that'll be, okay? So how many milliliters will we actually be giving? So we are going to take this number, and what we need to end up with is milliliters. So because I have micrograms here, I need to put micrograms on the bottom of this conversion. So for this one, I'm going to put the 500 micrograms here, and I'm going to put the 3 mils here. Okay. So and again, how many mils? We already know, and that's going to be our answer. So let's see, we can cross multiply. We can get rid of micrograms and micrograms, kilograms and kilograms. Okay. So now we can start multiplying across, and I'm going to put this down here. So we have 250 times 129.1 times 3 divided by 1 times 1 times 500. Okay, so we're going to get out our calculator, and I'm going to go 250 times 129.1 times 3, and I get 96,825, right? 96,825. Okay. And then I'm going to multiply across the bottom, 1 times 500, which I know automatically is just going to remain 500. Okay. Could you reduce these before you multiply? You can. I don't typically show this because if you struggle with math, it's just more confusing. But of course, you could cross this out and make this a 2 and then make that a 1, and that would make these numbers a lot smaller. But I'm not going to show that. If you know how to do that, great. Go ahead and do that. You should get the same answer. So now we're going to take 96,825 and I'm going to divide it by 500. So I'm going to take that, divide it by 500, and that equals 193.65. All right, and again, we know our answers need to be to the nearest tenth. So our final answer is going to end up being 193.7. And that will be our answer. All right, next problem. All right, so we have 62.5 milligrams per kilogram ordered, and the patient weighs 227.8 pounds, and the pharmacy sends us a medication, and it's in 2 grams in every 5 mils of solution. So this is kind of like the most complex the problems can get, because we have to do not only all the normal math, but we have a couple of different conversions we need to do, because we have pounds here and we need kilograms, and we have grams here and we have milligrams here. So we do have to do a couple of more additional steps here. So for this one, the important conversions to know is, first of all, that 1,000 milligrams equals 1 gram. And that the same one from earlier is that 1 kilogram equals 2.2 pounds. So those are those additional metric conversions that we need to know in order to do this problem. All right, so let's get this set up. We're going to start with what we have ordered. So we have 62.5 milligrams per every 1 kilogram. All right, so again, right away, I want to, again, I just set it up the same way, but it doesn't matter where you put the things as long as you have them correctly on the top or the bottom. But I know I need to get rid of this kilogram, so I'm going to start with this conversion right here and plug that in right away. So I know that 1 kilogram is equal to 2.2 pounds. Okay, so that's going to take care of my conversion from pounds to kilograms. And so now I just need to plug in how many pounds that patient weighs, which was 227.8. And that's just going to be over 1. All right. So that takes care of the conversion from pounds to kilograms. Next, we're going to add in my other conversion. Again, this is how I like to do it because I know I have the pharmacy sent me up something that's in grams and my order is in milligrams. So I know I need to get them to equal out the same as well. So I'm going to plug in this one here, and since I have milligrams here and I need to get rid of milligrams, I'm going to put that on the bottom. So I'm going to have 1,000 milligrams equals 1 gram, which is this problem right here. And then I'm finally going to add in what the pharmacy has sent us. So, and again, because this is grams and I know my answer needs to be in milliliters, I need to get rid of the grams. And because I have grams here, I'm going to have to put grams on the bottom of this last equation. So it was 2 grams and it's over 5 mils. And I know that my answer is going to be in mils. Okay. Let's see here if I can get it back out so you can see the whole problem. Maybe not quite, but you can see here. So here's the whole problem set up. So all these different conversions need to take place in order to get this answer. So I'm going to start by crossing out my like units. So I have, you can see right here, I have milligrams here and I have milligrams here. So those cross out. I have kilograms here and I have kilograms here. They cross out. I have pounds here and I have pounds here. Those cross out. And then if we scoot back over here, I have a gram here and a gram here. So what is left? Milliliters, and that's perfect because that's what I want my answer to be in. So you can see I've taken out all those different units and now I'm just left with the numbers. So I'm going to rewrite them down below. So it is going to be 62.5 times 1 times 227.8 times 1 times 5. Okay, that'll be the top. And then on the bottom, I'm going to have 1 times 2.2 times 1 times 1,000 times 2. All right, so that's going to be all these numbers into the math. So now we're going to get out our calculator and do some multiplying. So we're going to multiply across the top first. So 62.5 times 1 times 227.8 times 1 times 5. So 71,187.5. So we're going to get 71,187.5 on the top. And then on the bottom, we're going to multiply 1 times 2.2 times 1 times 1,000 times 2. So we should get 4,400 on the bottom. Okay, so now we need to do our division. So we're going to do 71,187.5 divided by 4,400. And then we should get 16.1789. And again, if we have to round to the nearest tenth, we are going to look at that 7. That 7 is going to make that 1 a 2. So our final answer would be 16.2 milliliters. Oops, sorry. So I divided this number by 4,440. I get 16.1789. We need to round this to the nearest tenth. So it's going to end up being 16.2. All right. Next page. All right, so now the next problem here is we have, again, a number of different conversions here because we have our order in milligrams and the pharmacy sends us grams. and we have pounds, and we need kilograms. So this one's going to be set up the exact same way as the last one, keeping in mind those two conversions that we need, which is 1 gram equals 1,000 milligrams, and 1 kilogram equals 2.2 pounds. Okay, we will need both of those. So let's set it up. So we have 6 milligrams per 1 kilogram, right? That's what the order says. Again, I know I have pounds here and I need kilograms, so I'm going to insert this right away. So I know that 1 kilogram equals 2.2 pounds. Make sure that your pounds doesn't look like a 1. Pounds. There we go. Okay, so 2.2. All right, now I'm going to plug in that weight, which is 352.6 pounds. And again, I have pounds here and I have pounds here, and so they'll cancel out, and that's over 1. Okay, so that part is set up. Now I need to plug in the rest. So again, I know that I have milligrams and I have grams, and so I do need to convert those. So I'm going to plug in this formula right now. And I know I have milligrams here, so I'm going to make sure the milligrams is on the bottom so that they will multiply out. So I know that 1,000 milligrams is equal to 1 gram. So that takes care of that on the for that conversion. And now I can plug in the rest of it. So I know that the pharmacy sent us 8 grams per 500 mils. And since I already have grams on the top here, I need grams on the bottom so that they will cancel out. So 8 grams goes on the bottom per 500 mils. All right, and we do know our answer needs to be in mils because we already know how much we're going to be giving. We need to know how many milliliters that is that we're actually going to administer. So here is how our problem is set up. I'm going to kind of slowly scroll across. All right, and now we can start crossing out like units. So again, we have kilograms and kilograms, which will cross out. We also have pounds and pounds. Okay. I have milligrams here and milligrams here. Those will cross out. And then if we scoot over a little bit, we can also see that I have grams here and grams here that will cross out. So now all of the units are crossed out, and what we're left with is mils, and that also matches what we want our answer to be in. So now we can do our multiplying, and again, I'm going to kind of go down here. So we're going to take 6 times 1 times 352.6 times 1 times 500. And on the bottom, we're going to have 1 times 2.2 times 1 times 1,000 times 8. All right, so let's get out our calculator here. So across the top, 6 times 1 times 352.6 times 1 times 500. We're going to get a huge number here. 1,057,800. Okay. So 1,057,800. Okay. And again, we could have made this smaller by crossing this out, making that a 1 and making this a 2. I just don't want to show that, so I don't want to confuse you, but that would make these numbers much smaller if we did that. So then we have on the bottom 1 times 2.2 times 1 times 1,000 times 8. And that'll give us 17,600. Okay. So now we can do our division. So we're going to take our top number, 1,057,800 divided by 17,600. And that is going to give us 60.102. 60.102. And again, if we have our answers to the nearest tenth, it's going to be 60.1 milliliters is what we're going to be giving. Sorry. So here's what our division comes out to. If we divide this by that, here's our answer. And then if we round to the nearest tenth, there's our answer. Okay, just a couple more left. These are a little bit simpler again. So again, though, we just need one conversion here because we have grams here and we have milligrams here, but we don't have any weight, so this is not a weight-based problem. So start with what we have, 825 milligrams over 1. And again, we need that conversion that we've used up here, right? So I know that 1,000 milligrams is equal to 1 gram. And now I can plug in this, and I know I need my answer to be in mils. So I'm going to put the 1 gram of this problem, okay, on the bottom, and then 50 mils on top. Okay, so let's cross out our like units: milligrams, milligrams, grams, grams. What we're left with is mils, and that matches what we know we need for our answer. So now we can do our multiplying. So we're going to take 825 times 1 times 50. And then on the bottom, 1 times 1,000 times 1. All right. So 825 times 1 times 50 is going to equal 41,250. So 41,250 on the top. And then 1 times 1,000 times 1 is going to be 1. Excuse me, it's going to be 1,000. So we're just going to have 1,000 on the bottom. So if we take that and get our math, we're going to get 41,250 divided by 1,000. And that's going to equal 41.25. So then again, we have to round to the nearest tenth. So our answer will end up being 41.3. So we will administer 41.3 milliliters. All right, and the final problem we have here is same type of problem we just have. There's no weight in here, but we do have two different units. We have milligrams and we have grams. So we'll have to set this up similarly. So I'll start with what is ordered, 1.5 grams over 1. And again, I'm going to put in my conversion, this 1 gram equals 1,000 milligrams, because I do have to do that conversion here. So again, I have grams on the top, so I want to make sure there's grams on the bottom. So I have 1 gram equals 1,000 milligrams. So those two will end up crossing out. And then I can plug in what the pharmacy sent me. So I'm going to take 2,500 milligrams over 10 mils. And that's how I'm going to set up my problem. I know that my answer needs to be in mils. Okay, that's in mils. And now I can get rid of my like units. So I'm going to get rid of grams and grams, milligrams, milligrams. I'm just left with mils, and that matches what I need. So now let's get our problem rewritten. So it's going to be 1.5 times 1,000 times 10 over, or divided by 1 times 2,500. Right. So with our calculator, 1.5 times 1,000 times 10 is going to equal 15,000. Oh, let me just check my math again. I just want to make sure I have that right. 1.5 times 1,000 times 10. Yep, okay, 15,000. And, oops, that's a 0. Sorry. And then across the bottom, we have 1 times 2,500, so that's just going to be 2,500. So then we are going to do our dividing. So let's get my calculator up there a little better. Okay, so 15,000 divided by 2,500 equals 6. So in this case, we are going to administer 6 milliliters. All right, so I hope that's helpful. Like I said, once you get into a pattern of setting them up the exact same way every single time, it really simplifies this process, and you know that you have it set up right when everything can cross itself out and you're only left with one type of unit left.